Greetings, it's me, Loose Juice. Today I have two exciting new developments to share about my game engine, Omni. Since the last video, I've completely rewritten the renderer and introduced a brand new system into the engine, called the Asset Manager. In this devlog, I'll be sharing why I rewrote the renderer and what this new system does, and my hope is that along the way, you'll learn something that you can apply to your own projects. In case you're unfamiliar, the renderer is essentially the part of the engine responsible for displaying things on the screen. Previously, the engine's renderer used a rendering library called BGFX, which supports an incredible number of devices. You really can use it to render on anything you can think of. I chose it for this reason, and it worked well for me for over 2 years. However, I ran into some serious issues with it a week or two before uploading my last video. I decided that if I'm serious about making this engine, I really ought to write my own rendering code that I can actually understand through and through. In addition to this, I realized that in order to support a good number of devices, all I need to do is to use the two rendering APIs called OpenGL and Vulkan. OpenGL and Vulkan are both essentially sets of tools that you use in your code in order to draw stuff on the screen. I want Omni to use both of them, since together they support a wide variety of devices, but as of now, Omni only uses OpenGL. OpenGL is kind of like the grandfather of all the other rendering APIs. It's one of the oldest still in use, and I think the others take inspiration from it. I decided to start with OpenGL since it's much easier to use compared to Vulkan, and I've been familiar with it since high school. OpenGL is really slow by today's standards, but it's a solid fallback option if someone's running the engine on older hardware. Vulkan is much newer than OpenGL, and is much faster too. However, it's notoriously difficult to use, so I'll probably wait until more systems get introduced. The old renderer that used BGFX was blisteringly fast, but unfortunately the new OpenGL renderer only has a fraction of the power it had. This is due to a couple things, namely that the BGFX renderer used Direct3D 11, which is another rendering API generally faster than OpenGL. This one is exclusive to Microsoft devices, however. The power that this new renderer has is certainly acceptable for now. I just miss how fast the old renderer was. When I get around to implementing Vulkan, I'll do some optimization, but right now I think it's fine. Also, most of the renderer code is from the Cherno's game engine series. Most of the basic stuff is exactly the same, but things like the camera system I made on my own. I always feel a little embarrassed to use code from a tutorial, but I really feel like he's the best person I could be learning about this from. I always take the time to really and truly understand the code before using it as well. One more thing before we move on. I'd like to share a realization that I had during the process of writing the new renderer. Although BGFX is used by a great number of people, there's not really a ton of people talking about it online or making tutorials on how to use it. This led to me not being able to fix certain things and not really understanding how to implement certain functionalities. But for OpenGL and Vulkan, there's an endless sea of tutorials and forums, which makes it much easier to understand them and fix things when something goes wrong. I realize that when it comes to choosing third-party code to use in your project, it's extremely important to consider how popular it is online, because popularity usually means that more people will be using it, talking about it, and making tutorials for it. Even though BGFX is incredibly powerful, because I wasn't able to learn more about it past the documentation and examples on its page, it really hurt my progress and the quality of the engine. There are a few BGFX tutorials out there, and the creator of BGFX has a Discord server where I spoke to him a few times about issues that I was having. However, the number of outside resources simply isn't enough for me, and the creator has a lot of people to help, so I'd rather not bother him so often. I've designed and almost fully completed a brand new system in the engine called the Asset Manager. The Asset Manager is responsible for handling files that the engine requests. For example, if you have an object in your game with a sprite component, you can simply drag and drop the texture you want it to use into the sprite component's texture slot, and the Asset Manager will take care of the rest. By this I mean it will load and unload the texture file whenever necessary, among other things. The Asset Manager can essentially do anything you would think to do to a file on a computer. It's easy to use and pretty powerful, so I'm really satisfied with how it turned out. The way that the Asset Manager keeps track of all the files that the engine needs is through something called an unordered map. An unordered map is basically just a list whose order doesn't matter, and each entry in the list has a key and a value. The key is a unique ID that identifies the entry from the others, and the value is the actual data that the entry holds. Once every second, the Asset Manager scans the project's asset folder for new files, and when it finds a new file, it registers it into its unordered map, which I refer to as the asset map. It registers the new file by generating a unique ID to use as the file's key, and then stores the relevant information about the file and its value, such as the file path and the type of file it is. Now that the file is registered, the Asset Manager can keep track of it. When a file is actually loaded, its data is stored in another unordered map that uses the same key but stores the file data and its value. In order to store the file information while the engine isn't running, the asset map's IDs and file information are dumped into a .assetmap file. The file is saved every time an asset gets registered or unregistered, and the Asset Manager reads it when the engine starts up. There are certain types of assets that can be handled in different ways, so when they're registered, a .assetprops file is generated. This file contains information about how the asset should be handled. For example, an image file can be used in many different configurations. It can have different filtering modes, wrap modes, or have bitmaps generated for it. Naturally, the Asset Manager knows that it needs to load an asset if the asset is requested and isn't loaded yet. But how does it know when to unload something? Basically, every loaded asset in the asset map keeps track of how long it's been since it was needed. If this time exceeds the limit, then it gets unloaded. Honestly, I don't know how good of a solution this is, but it seems to do the job well enough. The Asset Manager is able to hot reload assets. This means that you can make a change to a file, and the Asset Manager will detect it and reload the asset immediately. This sounds simple enough to do, but finding a reliable way to detect when a file has changed was actually pretty tricky. First of all, I need to acknowledge just how surprised I was that my last devlog got so popular. I was convinced that not many people would like these types of videos, but I guess I was wrong. So, even if that was just me being blessed by the YouTube algorithm and it never happens again, thank you all so much. Anyways, it really feels like Omni is starting to become a real, actually usable game engine. I think I say this every time I implement some new stuff, but the Asset Manager has brought so many things together that I can't help but think it. I'm not totally sure what the next devlog will be about at this point in time, since I kinda have two different features that I could implement next. However, I think either option will turn out to be pretty cool, so I hope that you'll look forward to it. I'll see you in the next one. I hope you enjoyed and have a good day.